Hello, everybody.
Hello, everybody.
Audio works. And, yeah. So, last we were working on the CTRE parser thing. Today, the project is fix the fix the left to right association so that it's actually left to right instead of right to left. Um, so let's get back to our parser here. And yep, last time what we did is we refactored this so that we moved all the special case code. This function, this was like the very first refactoring, was splitting this main up so that main was just main and not a big bunch of other stuff. And then splitting that to different parts like the tokens and the parser. And parser got its own CPP file. Woohoo! So, the problem that we have is in this test here, where we're testing left to right versus right to left association, it's in fact asserting right to left association, which is in fact all wrong for things like with things like plus. For example, this should be 8 minus 5, which is 3, minus 2, which is 1. But instead it's getting interpreted as 5 minus 2, which is 3, and then 8 minus 3, which is 5. And so, yes. Oh, I should fix this. But that's neither here. Our goal is to break this test. And I should add another test for involving factors. We'll just say right associative expression. And then we will add another given for right associative factors. And here we will do something 8 times 5 divided by 3. So 8 times 5 is 40. 40 divided by 3 in integer math, which is what we're doing. So 40 divided by 3 is going to be 13. But 8 times 5 divided by 3, well, if we do the 5 divided by 3 first, in other words, it's left associative, then we do 5 divided by 3 will end up being 1. And 8 times 1 is going to be 8. And so that's the answer we'll get out. And so this one is also going to change. And And then this is going to be prog n star and then slash and then 3. That is how that is going to work out. And the answer that we should get out should be 1. Or not 1, it should be 8. So let's make sure that this new test that we've added, in fact, runs. And indeed, it does run. And let's just make sure that it doesn't run when it's not supposed to by putting that there, just to make sure that our test is actually being seen. And indeed, it is being seen, and we're getting the wrong answer. Okay, that's good. Okay, so, and of course, this should have been right here, should have been, well, of course, if the test wasn't executed, it wouldn't matter. But now we can see that our test does indeed fail, or properly test to make sure that these are right associative. Now, that's the problem, is it's not supposed to be right associative. And that's what we need to fix. And I was playing Factorio with somebody. That's okay. I don't care whether any of you know whether I was playing Factorio or not. And there I was upgrading JetBrains. So there we go. If we do a diff, we'll see blah, 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 blah. What does the... I'm always curious what the AI wants to do for a commit message, because sometimes it enables me to feel superior to the AI. Yes. And let's check to make sure that this is, it's too long. There we go. So, there we go. Right? Test improper for now, right associative factor expressions. So this basically sets it up so that we're testing the two different kinds of expressions that we have to make sure that they are both handled in a right associative fashion. Even though they're actually supposed to be being handled in a left associative fashion. And our job will be to fix them to see if they are, to make sure that they are handled that way. So, why are they actually being handled in a right associative way despite the fact that they're supposed to be left associative? And it's all my fault, because, it's always all my fault. And it should be right? That's what it should be. And And the same here. It should be term or term that's the problem in the production, and that production is mirrored in the way the code works. So the way we should be handling this, and we'll fix them one at a time here. For parse term, the way we should be handling this right now is currently we look. Is our parse factor, so we got a factor, right? And that was what it originally said, is for term, we should see a factor. And then we check, okay, are we at the end? And if we're not at the end, then we look, are we looking at a multiplier divide? Okay, then we should be seeing another term, which might be just a plain old factor. And that's actually wrong. What we should be doing here is if we see an operator, it should be if it's not equal, and it's not equal to divide. If remainder equals finish, and so basically if all these conditions are met, if we are seeing, if we're not at the end, or if we're at the end, no. If we're at the end, then we should just say return the factor that we just got, because we clearly just got a factor. And then, otherwise, and this isn't otherwise because we have an early return here, right? So otherwise, if we're getting if the next thing happens to be an operator, well, this one, because of the way we're doing this, we almost have to do it this way. So if we happen to be looking at an operator, but it's not then we return this. And then here, again like this. So basically, if we get to a situation where we're at the end, like, oh, we didn't see a multiplier divide, and we didn't see a, what's it says? Then we just go, okay, we got a factor, and that's it. But if we did see something like that, then that means that we're actually a term. This is really tricky. This is really tricky. Because if we say, okay, we're seeing something that's more than a factor, let's parse term again. Well, this just ends up with infinite recursion. And so this is a case where we kind of have to say that we're actually returning a term. So for parse nodes, do we have parse nodes? No, we have parse nodes for term and factor. You know, we don't actually need parse nodes for term and factor. We can have parse nodes for binop instead. We actually should fix that. That's a thing that we should refactor. We should change this so we don't have parse factor. We instead have parse binop. No, that's wrong. That's wrong. We should still have parse term and parse factor. Those are our productions. But the things that they should produce, like we have parse node, and then up here, we're declaring a bunch of different kinds of parse nodes, aren't we? Yeah. Okay, yes, we do call it just plain old binary operation. Okay. Okay. Why am I stuck here? So the reason why I'm stuck here is in order to make parse term work, well, I can't just call parse term down here when all of this stuff fails. Like this return statement doesn't belong here, right? I come down all the way down here, and it's clear that, okay, yes, I found a factor, but it's not at the end, and it's followed by a multiplier divide. So it's in fact more than a factor. And I have to treat it as an actual term that might contain another factor. In fact, it has to contain another factor. Now, there are a bunch of different ways I can do this. And that's the crux of the issue. So there's a bunch of different ways that I can do this. The naive way of just calling parse term is just going to result in an infinite loop, right? So, what do I do? Now, if I called parse term on the thing that's after the multiplier divide, that should also be a term. It might be just a factor, but it should also be a term. But that's what I was doing before. And that resulted in the tree being all wrong. It ended up being the tree such that the left-hand side was evaluated before the right-hand side was. And it should be the other way around. The right-hand side should be evaluated before the left-hand side is. And in order to make that work, it's not even that the left-hand side should be evaluated before the right-hand side. It's that the left-hand side needs to contain like the first two parts of the expression, right? And then the right-hand side contains the rest of the expression. And so I need to check what I get back from this. So one way is to check what I get back from it. Do I get back a binary operator when I try and do it? But the trick is I'd also have to check to make sure that the binary operator was in fact a multiplier divide. Because if I get back a multiplier divide, I should take apart the binary operator and move, I have a... Let's go to this test here. So I have a structure that looks like this, right? These are each tree nodes. So if I make a comment describing what this looks like, it's something like let's see what happens if I do this. Okay. This was some kind of network thing that I was talking about. Do I have this actually saved? So what we'll do is we'll just do new, right? Okay, create new diagram, blank diagram, or chart class diagram. We'll call it a class diagram. No, blank diagram. Entity relationship. That's not exactly right. We'll call it a blank diagram. Okay. So here we have a bunch of nodes, right? We have this node, and then this node. And here we have, oh, come on. And we also have that node. And let's just, now we can, there we go. Perfect. Okay. And then it goes from here, and then to there. And this one goes from there to there, right? And then we have another one. Like that. And then we'll draw in some more lines from here to here, and from here to here. And we'll stick some text in here. I think we can get some text in here. Do we have a tool for that? Miscellaneous? No. Advanced? No. I bet there's some kind of tool to get some text in there. How do we get text? Miscellaneous. All right, there we go. Text. So, go back here, right? And we're going to just going to put this in the background for now, because it's not important. I'm keeping it around just because I don't know its save status. I don't want to mess around with it on stream. So, look at this. we've got star, and then 5, and then 3. Right. So star, right. And then this one is 8. And then this is slash. And then 5. So 8 times 5 divided by 3, right? So 5 divided by 3, so we get this, we get this out. This is, in fact, like if we actually go up here and put a title up here, this is the way the expression 8 times 5 divided by 3 currently parses. And the reason why it parses this way is because we see the 8, go, okay, we got an 8. And we see the star. We go, oh, this is something more complicated than just a number, right? So then we say, okay, well then, we recursively parse the rest of this. And so it looks at the rest of this and it goes 5. And it sees, oh, and it's a slash. That means this is more complicated. Let's just invoke something to parse the rest of this. And the rest of this goes 3. Well, that's just a factor. Turns it as a factor. Turns it as a numeric literal. This thing gets it, goes, or this thing that's parsing all of this gets it and goes, okay, I have the 5, and I have the slash, and I have the 3. Let's combine them. And so that's what we get when we combine them. This is a binary operator. So then it goes, okay, and then we're going to pop back up here. And this bag goes, okay, I got my left-hand side, which is the 8, and then I asked to get the right-hand side parsed, and I got that. So that's a slash, right? That's all this stuff. And so I got to parse all that. And so you do that, and then you got back the answer. You got back the answer, which is this whole assemblage right here. And so then it goes, okay, that's my left-hand side. So my right-hand side is 8, my left-hand side is this, and it's star. And then it returns that back up. It goes, okay, got it. Bloop. That's my parse. Well, you look here, and 5 and 3 are basically stuck together in a way that they shouldn't be. It should be 8 and 5 that are stuck together, and then the divide. So it needs to be rotated, right? What this needs to happen is this needs to be rotated so that this becomes that one's left-hand side. This becomes this one's right-hand side. But in order to know that you rotate it, like this one, it gets a 3, right? Well, it's not a binary operator, so it shouldn't be rotated. Well, okay, so it doesn't rotate it. And then it turns itself and it goes, I'm a binary. This one goes, okay, I got a binary operator. And then it goes, well, and let's try and rotate it. And it tries to rotate it, and it succeeds. But suppose this one instead was plus. Well, then it shouldn't rotate it. But it can't tell that. Like, it sees a binary operator here, and it goes, so it would have to check, is it a binary operator? And then it would have to check, which binary operator is it? And that's a lot of checking, right? And then it goes, okay, if it's the binary operator and the binary operator happens to be, a slash or, something that's on my precedence level, then, okay, I should rotate it. Suppose this one was like a plus. Would that still be the right thing to do? Well, it never would get a plus back. When this went down here, it would never get a plus back. It would just get the 5. Because the 5, it would try to parse the 5 and then it would go, is this a slash or a star? It's not. Go, okay, I just returned the 5. That's my factor. And then the upper level would handle the plus and go, it would do the plus and then the 3. And so it would never see a plus down here. So if it gets a binary operator back, that binary operator is going to be, but is it going to be in all cases? Would it be possible to manufacture a case in which, in fact, it would be using parentheses? So, no, it can't do that. It can't decide that arbitrarily. Because here's the situation that wouldn't work. So here's what we're considering. We're considering, okay, when it comes back up here, it looks at this. Is this a binary operator? If it's a binary operator, then do this rotate operation. But that doesn't work. And here's the reason why it doesn't work. And I'll put the little thingy in here. It's about why it doesn't work. So you try and do this, right? 8 times 5. Okay. Well, in the parsing, the parentheses disappear. And so you get 5 plus 3, and you get plus is a binary operator, right? Okay, and then it tries to do the rotate. And then it binds together the 8 and the 5 over the 3, and that's wrong because there's this parenthesis here, right? So it can't do that. So, no, this won't work. So what's another way to make it work? The other way to make it work is to just explicitly go, okay, I'm just going to have a list, and I'm going to keep on going through the list, grabbing operators and grabbing factors until I get to the end of the list. Until I get to something that's no longer the kind of operator that will fit into my list. Because I can only have two kinds of operator in my list. I can have star and divide, and if I have anything else, it's wrong. So we're just going to do this until we get to a star or a divide that's not, yeah. Yeah, until we get to an operator that's not a star or divide, we get to something that's not an operator or whatever, then we're at the end of our list. But as long as we can see a plus star or divide, that means we can continue appending to our list. Sure. That works. And then we can build up our list in reverse and make everything come out the way we need it to come out. And that means it needs to be a deck. So that's another way of doing it. And the rotate operation I don't like because the rotate operation we'd have to check to make sure about the kind of operator that was down there, that it was a binary operator, and that it was blah, blah, blah. And then if it was, and it was, the right binary operator, then it does the rotate. And that's a complicated operation. I think it's just easier, even though it's kind of special casingness, it's just easier to make it into a list, or actually in this particular case, I'm going to make it a deck. Okay. So, right, there you go, deck. And then here, down here, where we're parsing these factors out, parsing out all the terms, what we just say is and then parse result t and what is in tokens.hpp here. So we have a bunch of tokens, and then we have a struct. No, we don't want to type the colon over here. We want to type the colon over here. There. Okay. If start equals finished, if we're at the end, then yep, there's nothing left to do. We're done. Otherwise, we find out, can we parse a factor? If we can parse a factor, then we're going to put while true here, and then maybe we'll be able to come up with a better list condition. No, we're just going to do while true. Okay. And here, I'm going to try and parse a factor. Do we get a factor? Yes. If we didn't get a factor, then we just break. Okay. Otherwise, we go like that. Okay. Oh. But factor is a unique pointer parse node. Oh, it's not a deck of parse result T. It's a factor, a deck of expr pointer T's. That's what it is. There we go. Now that'll work. Okay. Then check remainder of the production. If remainder equals finish. Actually, let me double check on something. All right. I am double checking on something because somebody wants me to do something tomorrow. I need to make sure that will work out for me. Yes, it will. I have somebody who's not associated with the stream in any way. There. And there we go. Show it as busy so nobody will. I have somebody who wants me to do something tomorrow, and I need to make sure I want to this thing that I need to do tomorrow, and I will need to move 3 hours of my work to some other time, and so I have this time blocked off at work. Looks good to me. All right. So, temporarily interrupt the stream for me to do something related to my day job. And All right then. Back to the programming. So, saw a factor. We immediately put the factor on our list of factors. Now we check. Is remainder equal finished? Then we break. So a lot of this gets gutted. I don't want to gut it because I want to keep the if conditions around. So are we looking at a So if we get a token, then we don't return here. We do operator, or if we get an operator, then we go, there we go, like that. All right. And if we don't get an operator, then now here, if we're trying to grab a factor, we should actually always be getting a factor. If we aren't getting a factor when we get here, then something's wrong. Yep. This is the move our start. Okay. So if we get here, complain that we expected a factor. And if we didn't get a factor, it's actually an error here. If we ever get to this spot and we did not find a factor, something is wrong. Because we only get to this spot when somebody asks us for a term, which terms should always start with at least one factor. And then the other time we get here is if we get a term and then after it we see multiply or divide. And when that happens, we also get back here and we should also be seeing a factor. So we should always see a factor here, and if we don't see a factor here, something is wrong. But if we get all the way here, first, there. So one thing we should see here is that the size of our list of operators should always be one less than the list of our factors. Which, if we look at the expression here, right? Why did it end up with an extra slash? We should see, there's 2 operators and 3 factors. And that's how it should always be. There should always be, like, just to have this part, it would be 1 operator and 2 factors. So there should always be one less one less operator than factors. And we don't want to do any subtraction because then, no invoking overflow. Although, of course, the size might be too small and that might be an overflow. But, or the size might be too large and that might be an overflow. But we won't worry about that right now. That would be ridiculous. We'd be running out of memory. So now we get to a question. Indeed. So all the operators aren't empty. And we grab the last operator. And is this correct? Indeed, that's right. Operators.popback. Left equals factors.back. No, this is wrong. Okay. That's implied. The factors.size has to be greater than or equal to 1. So why am I going back up here and messing with start? Because I'm realizing that I kind of need something to return as the remainder at the end of this function. And the thing I'm going to have to return as a remainder is start, which means I'm going to have to be advancing start all the way along here, which I did down here, but I also have to do it here. And so that's what I'm doing here. Is making sure that start always points at the remainder. So that when I get down here, that's the case. That start is pointing at everything that I haven't parsed yet. Okay, so here we're just going to say, okay, our top is going to be our current factors. And then if we have some operators, then we're going to grab the operator, we're going to pop back, and then we're going to say left no, we're going to say binary operation, and then binary operation takes the operator, and then it's got this wrong. The left is not the top. The right is the top. Yes. Because the right is the back one, the last one that we parsed. And so the top is the last thing, thing at the end of our parse chain. We're doing the right thing. No, the left should be the thing at the end of our parse chain. So the left has, no, it should be the right. It's the right that's the thing that's the end of our parse chain. Which top is the current thing that's at the end of our parse chain. And actually we should make the top the first thing. All right. Like that. The reason why these are two separate operations is because this might throw an exception. Or pop front might throw an exception. And so this can't throw an exception unless, of course, there is no front, in which case you shouldn't have been calling it in the first place. And they don't want this to be able to throw an exception because they want it to succeed or fail without making any changes. I'm going to have to kill this person as a bot. Some bot just posted in my thing, and I'm going to have to go deal with that. And good. Okay. And in order to basically call this guy the bot and ban him the way he deserves, I wish I could also report him, but I cannot. So ban the obnoxious bot who just posted in my chat. Which reminds me, it's a thing that I missed doing here that I should do now. And then Twitch Stream maintenance type stuff. Sorry, everybody. All right. Now back to programming. Okay. So top now represents all the stuff that we've gotten so far. And then op. And then we do this, and then the left should be top, and then the right should be factors.back. No, it should be factors.front. And then front like that. Oh, no. And then we do pop front. Now we could try doing factors in place.back, but we're not doing that. We're just popping the front, and we're keeping basically our current working thingy in top. So we're going to do this, like this. Okay. Then like that. That should work. Let's see if it compiles. All right, let's try and run it. Oh my, it didn't like that at all. All right, what went wrong here? By inspection, let's see if there's anything obvious. While true. We have a bunch of cases in which we break. First, we break by return here. We just go bloop and return and go, yep, we failed. Otherwise, we go, okay, we got a factor, and we put it into our list of factors on the back, and we say start equals remainder. Okay, which basically goes, okay, our start is now everything that's left. And so yes. Then we go, okay. If we still have something after that, if we aren't done, but if we are done, then we're done, and we can break. But then let's look. Okay, are we looking at an operator? We're not at the end, and we're looking at an operator. If we're looking at an operator, then we go, okay. No, actually, it should be like this. Yep. And it should be or. There we go. That's the problem, the sense of this comparison. So are we looking at an operator? If we're looking at a multiply or divide, okay, then we found a new operator, and we add it to our list, and we go after the operator that we just found, and do this thing. Otherwise, we break. And if we aren't looking at an operator, we also break. All right. I bet this will work better. Indeed. Right associative doesn't work, which is exactly the one we wanted to fail. We wanted right associative to not come up with the answer that it gives. And then it fails at a certain point. So let's go into our test where it fails here. So it fails here where it says 8. And then it doesn't get to the rest of them, because require is like that. Require, if it fails, then it doesn't do any of the remaining requires. And so here We didn't get 8, which we shouldn't have, because now it's doing it correctly. Now it's doing 8 times 5, which is 40, divided by 3, so this should be 13 and not 8, which is exactly the answer we got. And this should be like this now. Like that. And this should be star, actually it should be slash, in fact it should be slash 53 like this. And then, except not, it should be, and then here should be star 8, 5, like that. That's how this should look. Let's see if it runs now, if the test succeeds. Okay, what does it not like now? I got the spacing slightly wrong. Oh, too many parentheses at the end. I only need one parenthesis at the end. There we go. Like that. And I should also say, change this test to say left associative factors. I wanted to leave the test in place to have it fail so that we knew that, it was failing, and then change everything to be left instead of right. And, this comment was always wrong, but we'll fix it now to be right. Like that. Yay! It succeeds. Okay. So there, one successful switch. We switched terms from being left associative to right associative. We kind of had to cheat a little bit. We had to create this deck instead of doing it recursively because, yeah. Could we have done it recursively? They could have done it by looking for the thing and then peeling off the last factor and saving it as, okay, we're going to grab the last factor, and if it, no, we couldn't have done it. We'd have had to do the whole rotation thing, which I don't like, because the rotation thing then has to look at the return to find out whether it's a binary operator. If it is a binary operator, which binary operator it is. Nope, this is the cleanest way to do it, is to basically compile it in a list and then do all the switch arounds to make it be actual thing. Okay. So, what does the AI think we did? Just well, it got that basically right. There we go. Got to make those commit messages pithy, one-liners. less than 72 characters. Or, well, 72 characters or less. Make star and slash left associative instead of right, and make test match. Now make is redundant. Possibly could rephrase it to eliminate the redundant use of make, but this works. All right. So there's that fix. Now we get to change parse expression to do basically the same thing. And we'll just apply the same technique here. And here, first of all, we did change the comment already. Oh well. I should have changed the comments one by one and stuff, but I didn't, and that's okay. So there we go. We started empty. We go, yep, it was empty. In fact, what we do here and again, when we get here and we didn't actually get a term, that is in fact an error. We should never be calling parse term when we're not expecting a term. Although that doesn't matter, actually. I might want to remove the error message from here. Maybe I should put an error message in here or something. Maybe parse result should be a somewhat more complicated thing that also includes an error message if it's a error parse. I can change that later. The fact remains that in our current grammar, if we ask to parse a term and there's no term there, that's an error. Yes, that is an error. Otherwise, you got a term. And so then we say like that, start equals remainder. Now we check. If got an operator, and if the operator is plus or minus, then we say we add it to our list of operators, and we say the start is after all the operators. Yep. Like that. Else break, else break. So basically, just like this guy. And then down here, we have the same kind of thing with our assert. And we do the same thing. So top is move terms front, pop front. Let me look. Operators pop front. Da 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 da. Binary operation op value move top. Da 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 da. Term pop front. Yes. All right. Just like this one does. The AI faithfully copied the code from down there. This is nice. All right. Apparently, there's yet another update to CLion. They're releasing them Fast and furious. This is like the second update in a week. How annoying. Okay. Let's run it. This should work just great. I mean, this I expected. I meant it should compile just great. And then here, it should complain when we go that fatal error condition. There was an assert failure. Oh, how my. When tokens are parsed. Oh, there is a SIG abort. That's the problem. Well, why did the SIG abort? Let's run it in the debugger and find out where the SIG abort happened, because I'm a little surprised that there was any kind of SIG abort. Okay. So we were in here on this line. Oh. Okay. Operators.size, zero elements, terms.size. Well, oh, I forgot something really, really important. Yep, there we go. That's the important thing I forgot. As it happens when you let the AI do too much coding for you. And in fact, down here, see, we did it there. Need to do it here too. There we go. Now we're getting the error I expected to get, which is a failure because this doesn't come out to quite the right thing. Oh, well, this one failed because the expression didn't show up correctly. And there should have been another one that failed because this evaluate here gave the wrong answer. And so we will go to this one here. This one. So this one, got to change it to say left. And then we say right, that's what we should be getting out of it. And here we need to change these parentheses around so that it's correct. Right? And expression is left associative. Tokens are parsed. Expression is left associative. Da 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 da. And also here, this needs to be changed. Like that. That's what it needs to look like. Okay. Now let's see what happens. We should still get an error because we didn't fix the other one. Oh, I forgot to change it to say 1 because it should be 1. Because 8 minus 5, 3. Minus 2 is 1. Yep. So that all worked, but now the one that doesn't work is this one. The parse tree doesn't look right. Which, yep, indeed, if it's left associative, it should actually look like this. Like that. Oh, also this one should change. There we go. That worked. All right. Left, left, left. Here, change left to right a whole big bunch, but there's also this one down here, which is related, changed to an unrelated test, just happened to have the wrong infix and prefix strings. So there we go. All right. What does the AI make of this change? Yeah. That's the change here. All right then. Well, so remember how last time we added all these tests so that we could refactor, and now the tests were used to verify that the only thing we were really changing was the associativity. Yeah, this is all so good. I want to double check that this comment is correct. Yes. Yep, yep, yep. Yep. Okay. That is all correct. Good. So, I think that's conclusion of the stream for this evening. As I said, all the tests that we added made the refactoring that we did last time much easier, and then it's made this time of fixing the associativity much easier, because we were able to make a bunch of changes and not worry that we'd completely ruined our program. That the changes were as localized as we hoped they were, and that everything else continued to function as it was supposed to function. That, parentheses still worked and everything else. So tests are really great for being able to do that kind of thing, to be able to be free about making changes to your code and confident that your code still runs after you make the changes, because your tests will catch the problems. And I think that's the overall lesson here. There's a whole bunch of errors here, but I don't know that I really care about any of the errors. Yeah, this is basically exactly what I want. And plain D is too stupid to understand standard format is the problem. Anyway, as I said, stream's over. As nobody asked, nobody that I saw that showed up to ask questions. So, oh well. Should be, I hope to be around maybe Saturday. And I'll be around Monday if I'm not around Saturday. And I'll be around Monday even if I am around Saturday. So you can be guaranteed to reach me at on Monday. I should be streaming here again. And on I might be here also on Saturday. I hope that you all have an excellent day. This parser thing is going to go on for a little while longer. There's some more complications I want to add to it. It's still a toy. I don't intend to turn it into a real language. But there are a few more things I want to add just to see that I can. And then I'll be done with it. I'll feel like, okay, I know how to write this in C++. One last thing I might do is fork the standard library to fix standard distance. But in order to do that, I have to demonstrate that it in fact has a real effect, and I'd have to make some kind of massive thing to parse to do that. Maybe, I don't know. Anyway, I wish you all a good rest of your